Here's the answer for day 2, problem 1. Given f of x is 5x and g of x is x squared plus 15x, find the following combinations of functions. Question A, let's add function g and f. So function g is x squared plus 15x, and let's add to it function f, which is 5x. This is going to make the answer x squared plus 20x. Question B, g divided by f. So start with function g, which is x squared plus 15x, and let's divide that function by function f, which is 5x. Here we're dividing a binomial by a monomial. Just divide each term of the numerator by the denominator. So we have x squared divided by 5x plus, and then let's do the 15x divided by 5x. X squared divided by x kind of works like this x cancels away one of those x's, leaving one left over. That will create x over 5. Another way to think of that is to use the rule about to divide powers, you subtract the exponents. An exponent of 2 in the top, subtract the exponent of 1 in the bottom, would create x to the first power in the answer. Now over here, the other term, this x and this x cancel away. 15 divided by 5 makes 3. So we have the answer x over 5 plus 3. Question C, we're going to do the composition of g with f. The letter g is written first, so we're putting function f into function g. So up here in the original functions, we're going to take function f, which is 5x, and put it into the variable for function g, here and here. So it's going to look like 5x squared plus 15 times 5x. 5 squared is 25. X squared is x squared plus, and 15 times 5x is 75x. Sorry about that. There you go. Now, day 2, problem 2. Solve the quadratic equation by completing the square. Here we have a trinomial, but it's not a perfect square trinomial. If we take half of the center number, that would create 1. And if we square 1, it makes 1. So we would like this constant to be a 1 instead of a 2. So let's make that be a 1. So we have x squared plus 2x plus 2. And if we subtract 1 from it, it will make it be a 1. Just remember, you also have to subtract 1 from the other side of the problem as well. So this now creates x squared plus 2x plus 1 equals negative 1. Now this is a perfect square trinomial, and it factors as x plus 1 squared, and that's equal to negative 1. Take the square root of both sides, and we have x plus 1 equals the positive or negative square root of negative 1. Now this is an interesting problem because over here on the right side we have the square root of a negative number, and that has no solutions in the set of real numbers. It does have solutions in the set of complex numbers. So in the next step, when we subtract 1 from both sides, we get that x equals negative 1 plus or minus the square root of negative 1. This square root of negative 1 part of the problem can be rewritten using the symbol I for the imaginary unit. And so here are 2 answers. These are imaginary numbers, not real numbers, for that original equation.